Hi there, boys and girls, and welcome back to Conquering Math, where it all adds up. Today we will be discussing the independent practice solutions to the greatest common factor lesson. Remember that you can pause or rewind this video as necessary to help you understand the problems. Let's dive on in. Independent practice number 1. Find the greatest common factor of 14 and 49 using the list of factors method. Now is a good time to pause this video and work on this problem if you have not done so already. The first step to solving this problem is to find the factor pairs of 14 and the factor pairs of 49. For 14, we find two factor pairs, 1 times 14 and 2 times 7. For 49, we also find two factor pairs, 1 times 49 and 7 times 7. We will circle the common factors, in this case 1 and 7, and then we will highlight the greatest common factor. The greatest common factor of 14 and 49 is 7. Independent practice number 2. Find the greatest common factor of 25 and 60 using the prime factorization method. Now is a good time to pause this video and work on this problem if you have not done so already. The first step is to find the prime factorization of 25 and then the prime factorization of 60. The prime factorization of 25 is 5 times 5, and the prime factorization of 60 is 5 times 3 times 2 times 2. We will rewrite these in numerical order, and we'll find the common pieces. In this case, they only share a 5. So the greatest common factor of 25 and 60 is 5. Independent practice number 3. Use either method to find the GCF of 35, 70, and 84. Now is a good time to pause this video and work on this problem if you have not done so already. I have chosen to use the list of factors method to solve this problem, but either method will work. I started by finding the factor pairs of 35, which are 1 and 35, and 5 and 7. Then I found the factor pairs of 70, 1 and 70, 2 and 35, 5 and 14, 7 and 10. And finally the factor pairs of 84, 1 and 84, 2 and 42, 3 and 28, 4 and 21, 6 and 14, and 7 and 12. Next, we will need to circle any common factors. You'll notice that I put 2 and 5 in red. That's because they are shared by two of the numbers, but not all three, so they don't actually help us solve this problem. In order to find the GCF of three numbers, it must be shared between all three of those numbers. The numbers that are in common between all three are 1 and 7. So next we will highlight the greatest common factor, in this case 7. So 7 is the greatest common factor of 35, 70, and 84. Independent practice number 4. Your Halloween bags were so popular that you have been asked to fill treat bags for the New Year's Eve party. You have 15 party hats, 24 noisemakers, and 30 New Year's necklaces. What is the greatest number of bags you can make with an equal amount of items in each bag? Now is a good time to pause this video and work on this problem if you have not done so already. You can use either method to solve this problem. I've chosen to use the prime factorization method. Remember that the first step of the prime factorization method is to find the prime factorization of each number. So first we find the prime factorization of 15, which is 3 times 5, then 24, which is 2 times 2 times 2 times 3, and then 30, which is 2 times 3 times 5. Once we write down the prime factorizations, we can look to see what is in common between the three numbers. In this case, the only factor that is in common between all three is 3. So the GCF is 3. You can make 3 New Year's Eve treat bags with 5 party hats, 8 noisemakers and 10 New Year's necklaces in each treat bag. Remember that you can pause and rewind this video as many times as necessary until you understand the process. Thanks for watching this episode of Conquering Math, where it all adds up. I'll see you next time.